All right. So you can start, Dr. Ala, please. Thank you.
Good morning, everybody, and assalamu alaikum. Today's session we will talk about the viscometers and how to measure viscosity and about the types of viscometers and this application especially in the petroleum fields. Muhammad. Firstly, what is meant by viscosity? Viscosity is resistance to flow, resistance of the substance to flow. Muhammad, okay, sorry. There are many types of some of influencers that can affect the viscosity of the substance. Temperature is the most important influencer. Increasing temperature inversely proportional to the viscosity of the substance. Also, the outside force, if we put forces or acting a force upon the sample, it will change its viscosity. Also, the inner structure of the sample itself may affect the viscosity. Ahmed? Hello, Ahmed? Before we talk about viscosity, we should know what is our fluid is. It is a Newtonian fluid or non-Newtonian fluids. Each fluid has its own viscosity. Each fluid has its own measurements, how to measure Newtonian fluids and non-Newtonian fluids. Newtonian fluids, viscosity stays constant. It doesn't change by the acting force, or doesn't change by any force, maybe rotational force or shear force or any force affected the sample. There is no change. While non-Newtonian fluids, the viscosity depends on the force applied to the sample. If we applied a force to the sample, viscosity may be changed. Types of Newtonian and non-Newtonian, it is another, we may use a broad term called rheology to know what is Newtonian fluids, non-Newtonian fluids. This term, I think it was illustrated in a previous webinar. So we will not go inside deeper to these terms. Only we will talk about viscosity. There are two main types of viscosity, dynamic viscosity and kinematic viscosity. Dynamic viscosity, if we want to know the viscosity of the sample in a dynamic motion, while kinematic in a static motion. Something like if we want to know the viscosity of petroleum fluid pumped in a pipeline or flows in the reservoir, we should know the dynamic viscosity. While if we want to know the viscosity of maybe lubricant, it is okay to know kinematic or measure only kinematic viscosity. Viscosity, eta, it is the shear stress divided by the shear rate. So it may be, dynamic viscosity may be known as shear viscosity because of the shear stress applied on the sample. How to measure viscosity? There are many devices that can be used to measure viscosity. Basically, gravimetric capillaries and the flow cups are the main or the simple procedure to measure viscosity, especially kinematic viscosity. Kinematic viscosity can be measured by gravimetric capillaries. There are many types of capillaries viscometers. Relies on gravitation. This method relies on gravitational force The gravity is the drive of this method. It measures kinematic viscosity mu by multiplying the measured flow time by the so-called capillary constant Kc. These constants need to be determined for each capillary by calibrating the capillary. Each capillary viscometer needs to be calibrated to determine the capillary constants of this viscometer. Disadvantages of this procedure: it is difficult to be applied to high viscosity. Several capillaries are needed to cover a wide. You may need several capillary viscometers to cover a wide viscosity range. But it is simple and cheap, can be used everywhere. There is no need for electricity, no need for any applications to do. Another type of the capillary viscometers is a pressurized capillary viscometers. Pressurized capillary viscometers, there are many types of pressurized capillary viscometers, depending on the method they be used, or the principle. One of them using weight, the other using electric drive. Such viscometer works in the same way as a weight-driven instrument. The weight is replaced by a driving motor, which relies on high shear stress values up to 900 kilopascal and the medium to high shear rate. This viscometer is applied especially in high viscous substances such as polymer melts, PVCs, greases, sealants, adhesives, and ceramic messes. I'm so sorry, the net cut. Pressurized capillary viscometers using gas pressure is another type of pressurized capillary viscometers. The drive force is the gas pressure. This device feature a glass or steel capillary of exact inner diameter and length. Gas force is through the capillary at preset pressure is a drive force designed for medium and high viscous, medium and low viscosity materials, such as mineral oils, paper coatings, and dispersion. And for polymer solution with low viscosity or medium viscosity to produce synthetic fibers of spinning machines. Another type of high pressure viscometers, or may be used in high pressure measurements of viscosity, falling ball and rolling ball viscometers. Falling ball, in this technique, a ball of non-dimension, non-density, rolls or falls through a closed capillary, which contains the sample liquid. Preset angle, you may change the angle of the falling. It may be from 10 to 20 to 80 degrees. If the angle increased more than 80 degrees, it will be called a rolling ball viscometer, falling ball viscometer. Rolling ball viscometer is between 10 and 80 degrees, while falling ball is maybe from 10 to higher than 80 degrees. It is used to determine viscosity, especially at high pressure. It determines only the kinematic viscosity, especially at high pressures. The indication angle of the capillary flows for adjusting the driving force Too steep angle results in too high speed of the pole, which leads to turbulent flow conditions and faulty in the results. It is very expensive because all of it made from steel or stainless steel of something like that. Dangerous because of high pressure measurements. Needs from its disadvantage also that its cleaning is very difficult. Ahmed, can you hear me? The new generations of viscometers or the basics of rheology measurements is the rotational viscometers. Rotational viscometers are used to measure viscosity, especially dynamic viscosity. If we apply a shear on the sample, we can you hear me?
Yes, doctor. Yes, we hear you.
Rotational viscometers basically consists of a cup containing the sample. The cup is matched with a so-called measuring spindle. Spindle is a unit which act or apply the force on the sample inside the cup. Depending on which part of the ribbon, there are two principles: seal principle with cut principle. The motor drives in seal principle. The motor drives the spindle or the POP inside the fixed cup, while in the other principle, the motor drives the cup itself, while the POP is stationary. There are different. There is no difference in the two techniques, but the serial principle is more easier, is more wider. It is used worldwide more than the code principle. In the rotational viscometer, there is something like there is some properties like torque and the speed of the speed of the spindle, the type of the fluid itself. If it is high viscosity, hello?
Dr. Ala, if there is any problem in the connection, may I continue? If you have a problem in the internet connection.
Hello? Can you hear me?
All right, Dr. Ala, I think there is a problem in your internet connection, so could you please let me continue the presentation?
Okay, it will be better. I'm so sorry, and I will try to be with you here.
It's okay, never mind. We understand the situation, and no problem. Thank you very much for the very first slides, which are really interesting. And let me please continue this presentation. We have reached the rotational viscometer, and we are continuing discussing this kind of rotational viscometer, which is based on the serial principle. This viscometer consists of the motor that drives the spindle that will rotate inside the beaker. I will just mute the microphone, please. All right. And number two here is the display that will show you all the test parameters, the speed and the result of the torque, the stand that holds the instrument, and number four is the spindle axis, and number five is the beaker that you fill the sample in it, and number six is the measuring spindle that causes the force to the sample. The preset parameter of the rotational viscometer is the speed, and the output parameter is the torque, and this torque is a measure of the force that will overcome the viscous forces of the tested substance, is a measure of its viscosity. And we are talking here about a dynamic viscosity that can be obtained by this equation. The dynamic viscosity can be obtained by the torque constant multiplied by the spindle multiplier constant multiplied by 10,000 over the speed that we will preset to the instrument, and all of these multiplied by the torque, which is the result of the instrument, the torque percent over 100. And this is the final result of our rotational viscometer, which is a dynamic viscosity. Actually, when we apply different spindles here, I mean different dimensions, different kinds of spindles, we can measure a wide range of viscosity from the low viscosity samples to the high viscosity samples, and rotational viscometers can cover the full viscosity range, as we will see later in the next few slides. Actually, these are some kinds of the measuring bobs or spindles for the rotational viscometers. Extensive quantity of different measuring bobs serves to test various types of substances, as we said before, and the relationship between the bob size and sample viscosity is inversely proportional. What is the meaning of inversely proportional? This means that the higher the viscosity of the sample, the lower the bob size that we should use. And this bob size, or the bob as general, should be sensitive in case we are measuring low viscosity samples, and should be robust in case we are measuring high viscosity samples. And this is the most important part of our measuring principle in the rotational viscometer. And we will see later in Anton Paar's rotational viscometers that the problem of or the issue of selecting the appropriate spindle and the size is automatically detected by the instrument itself. We have two different rotational viscometers called ViscoQC 100 and ViscoQC 300. And these instruments are budget friendly, they are really cheap, and they measure the dynamic viscosity of liquids from juice to gel, covering many applications. The 100 is different from 300 because the 100 only measure the viscosity at a single point, so we have no control on the speed during the test. Only we have to measure the viscosity in one speed value. However, for the ViscoQC 300, we can measure the dynamic viscosity as a multi-point in multiple points as viscosities, as different viscosities in the same time, and we have data memory, and we have options for two kinds of software that we can control. However, the 100, we don't have these kind of softwares, but we already have some free software that you can use and export your data into the Excel sheets and export data as you want to report later. It's ready to use out of the box. You buy it and then you use it directly. It has built-in digital leveling for the positioning and proper alignment. This is really important to get high accurate results. The magnetic coupling is now being used instead of the traditional screwing that is time consuming So the magnetic coupling, we will see in the video how to use it, and it's really easy. In few seconds, you can put the spindle and insert it in the instrument, and it automatically detects the spindle and guards. It's a different feature for the Visco QC 100 and 300, that it can automatically detect the type of spindle being used now. And also the guard. What is the guard? It's the tool that protects the spindle from being damaged. And also the true mode feature that can choose automatically the speed. If you have an unknown sample, you can use this feature to automatically preset the speed into the instrument. And we have air-cooled Peltier temperature device, which is advanced tool to control the temperature and guarantee its stability. And also we have 3 years of warranty and optional on-site service and calibration. Could you please let me show you this video? I know that the voice is a problem in Microsoft Teams for videos not being heard in Microsoft Teams. This is why I will show you the subtitles, and you can see it later. The link is in the presentation. I will share it with you. You can adjust the positioning, and this is the rack for the spindles, and this is the beaker, 600 milliliter. You put the spindle and the guard, and then you control the full instrument from the screen. Automatic spindle recognition by the Toolmaster feature. And automatic speed recognition by the TrueMo feature if you have an unknown sample. This is a quick show for the 2 instruments, but later we will see each instrument individually. Let's continue our presentation. And another very nice feature in the Visco QC instruments, that if your instrument and temperature device is properly aligned, how do you know? During the test and before the test. If you have a red color, then you have to adjust the 2 leveling screws that you have seen before in the video in the base of the instrument. So you have to adjust them until you reach the yellow sign in the screen, and then the instrument tells you to wait until the instrument stabilizes. After a few seconds, it turns into green, and here is a sign of that Visco QC is ready to be ready to measure your sample. And here is the visual alignment, and it's really user-friendly and increases the repeatability and accuracy of the results. If you have measured a sample with a wrong leveling or positioning, this will highly affect your accuracy and your results. Is your viscosity result fully traceable? What about the auto recognition of the spindle and the guard that protects the spindle? Once you put the spindle into the beaker and attach to the instrument, it will appear in the screen what kind of spindles that you are using and what kind of guards that are being used for this spindle. And this guarantee that you choose the correct one for the correct sample. How about unknown samples? As we said before, if you have any sample, you have to set the speed before you measure the viscosity. Why you have to preset the speed? Because if you have a low viscous sample, your speed cannot be very high. If your speed is very high and the viscosity of the sample turbulent flow and so on. And vice versa, if you have a highly viscous sample and you set a low speed as a preset, this will cause a problem for your motor. This will burn and maybe not working again. This is why you have to be within the range and you have to set the speed that is most appropriate to the sample that you have. If you are out of the range, the instrument automatically tells you by the true mode feature. And this is a magnetic coupling, as I said before. You don't have to use the traditional screwing mechanism. Once you put this needle, this spindle into the instrument, it magnetically attached to the instrument easily and quickly, and this saves your time and helps you align your instrument and begin the measurement. The spindles of Anton Paar are of highest performance. Why? Because it's made of a high grade of stainless steel with a low carbon content that is chemically resistant and very useful for very kinds of chemicals and safe for your samples, and it's frequently used instead of the other types of the stainless steel. This is why you don't have to worry about the corrosion or the effect of the sample on your spindles. The quality of the spindles is very high, and you can calibrate yourself easily. The spindle correction factor can be directly stored on Toolmaster, and this is the feature that is auto detect your spindle type once being measuring the sample. ViscoQC also shows you if you measure in the proper range. As I said before, it will show you green, black values on display if you are within the range. But if you are out of the range, you will see gray values. And viscosity is automatically calculated. You don't have to get the torque value and then you apply to the equation. The instrument automatically do it for you and take the torque value and then automatically calculates the dynamic viscosity and display it in the screen for any combination that you use. And the zero adjustment is what we have talked about before, that you need to position the instrument correctly, turning from the yellow color to the green color, and then you have the sign of the OK of the instrument that is ready to be used, and this ensures precise torque measurement. The accuracy is really high, and the repeatability also is plus minus 0.2%. And we have different kinds of markets that can be applicable for these rotational viscometers, the petrochemicals and food and pharma and personal care. And also, according to the applications, we have 3 modes of operation for the rotational viscometer. The first one is L. This is for low viscosity samples, and the R mode is for medium viscosity samples, and the H mode is for the high viscosity samples. But you don't have to buy a rotational viscometer for each mode. You just buy only one viscometer and you can operate on any mode that you want in the same instrument. You can change the mode. If you want a single point measurement, you can use the ViscoQC. If you want a multi-point measurement, you can use the ViscoQC 300, not the 100. And these are the speed ranges and the maximum torque for each application. And these are different kinds of samples and the torque type that should be used, whether low, regular, or high, according to your application. And there are many other samples that can be used, but these are the most frequently used. And these are the standard methods that we comply by this VSCO QC 100 and 300. And each kind of sample is complying to a distance standard method, ASTMs and ISO and so on. And we have pharma standards specifically for the pharmaceutical industry. Then we are talking about the temperature control by the Peltier device. We have two kinds of Peltier device that can be used. If your sample are like within the low viscosity, like some food and pharma applications, you can use the Peltier elements that can reach temperature control from plus 15 until plus 80 Celsius. However, if you have like petrochemical samples, you can use the PTD 175 that can control the temperature in the very low and very high temperatures, like from negative 45 until positive 175 Celsius. And also we have a temperature control on the beaker that you put the sample in it by the bath thermostat and PT100 sensor. You can put the sensor inside the beaker and you can control the temperature inside the beaker. And if you have a cover on the bath, this will keep controlling your temperature more and more. This can include a mounting clamp for the beaker. This is for the PT100 temperature sensor. This is a flexible cup holder. If you have a problem with positioning your beaker, this is really nice for keeping the cup holder fixed while measuring the sample. And this guarantees reproducible results and high accurate torque results. We have calibration oil standards, the silicon standards and oil standards that we can ship along with the instruments. And let's talk firstly about the VSCO QC quickly. It fulfills the pharma regulations. And it has the tool master, tool guard, and digital leveling documentation. And let's skip all these features and see this really nice video on YouTube on how to operate the VSCO QC 100. When you buy it, you can use it directly. These are the spindles that coming with the main basic instrument, and this is a manual. And these are stickers for the low, regular, and high modes that you can put in the instrument to show what kind of modes that you are using now. Firstly, you have to remove this safety transport, and you can transport protection, and you can use it later if you will transport the instrument into any place. And this is a sticker that you can put, and this is a power cable. You just select your language and click apply. You have the yellow sign, meaning that you have to adjust the positioning. You keep adjusting it until it turns into green. And here, the instrument is ready to be used. Now you come to your beaker. This cable is connected to the instrument to make you control the instrument from the laptop or computer, and you can download the basic software vCollect. And how about the sample preparation and filling inside the beaker? You simply set 500 milliliters of the sample into the 600 milliliter beaker. You put the guard that will protect your spindle, and then followed by the spindle inside the beaker. And you can also put the sensor PT100 inside the beaker to control your temperature and measure it. And you can adjust the positioning of the head of your instrument, and it's easily connected by the magnetic coupling. Automatically detects the kind of spindle that you are using. Once you connect the guard and spindle by the tool master feature, you have to reach this sign of immersion you can make it merged in the water until this sign appears. And this is the sensor, the temperature sensor. And now you come to the measurement. You click start, and the spindle keeps rotating inside the sample. You have to be within the range, the speed range that is appropriate for the sample, and you can choose automatically detecting the speed if you are out of the range and you don't know your sample. And automatically the results coming into your Excel sheet in the computer once connected. And that's it. You can change the mode into the inside the instrument easily from the screen. And this is how the measurement already done. The cleaning is really simple by cleaning the beaker and the spindle, and you can refer to the manual for the procedures. And let's go for the more advanced ViscoQC version, the ViscoQC 300. That is has a wide screen of 7 inches, and it's glass touch screen, and you can store your data in a memory, and you can use many customizable methods, up to 50 methods. You can store the data inside the memory, and you can export your data via any software version vCollect. PC software. This is the basic one that comes free with the instrument, and you can also purchase for more advanced software packages, as we will see later. if you are interested in some kinds of special measurements and methods. Let's see this video. This is a positioning as we discussed before, and you can control everything from this really nice user-friendly touch screen. This is how you reach the zero adjustment, and you are ready now to measure your sample. It shows you the torque and dynamic viscosity. You can choose any method that you want. You can preset the speed, or you can let the software automatically detect that according to your sample viscosity. You can type your sample name and you can store this data in the memory, or you can use a barcode to automatically screen the name of the sample. And so on. You can watch the video, the full video later. Actually, this is how the difference between the single point measurement and the multi-point measurement. This can be obtained by the viscoQC 100. You have no control on the speed or torque during the tests. However, the viscoQC 300, you can control the speed and change it while measuring the sample and produce a multi-point measurement to your samples. We have two kinds of softwares, and you can watch the videos of each software from here later, the V-curve and V-comply. And each one have some features according to your applications. You might be interested in some kind of methods like the yield method, the yield point method that determines the yield stress, the low viscosity temperature scan, the temperature ramp, any kind of models, mathematical models like the shear thinning index and so on, and also the V-comply that includes the audit trail, and it has delivery of the PQP pharma qualification for the pharmaceutical industry. And these are optional softwares that can make you have some control on statistical models and analysis of your results for different kind of applications. Thank you very much. I've reached the end of the presentation, and I'd like to hear the feedback from you. What are your questions? Please, you can raise your hand. You can type in the chat box. I'm here, and Dr. Ala is here. I wish the internet now is okay, so that we can answer your questions. Please, if you have any question, please raise your hand and open your microphone, or type into the chat box from here. Mr. Hisham Al-Wafi. Okay, can you please talk? Unmute your microphone and talk.
Hi, Mr. Muhammad.
Hello, Mr. Hisham.
Hi, everybody.
Hello, thank you. Hello.
Thank you, Dr. Ala, for the lecture. And I'm asking for viscosity index mode. Can the device measure it or like in DMA 3000 device in Anton Paar?
Like what?
The previous version in Anton Paar DMA 3000.
DMA?
DMA, yeah.
Yeah. Actually, here we can talk about another kind of viscosity, which is the kinematic viscosity. And actually, we didn't go for this kind of viscosity. We have the Stabinger viscosity that is a patent from Anton Paar that is based on the YouTube density method that invented before, that we have the session before. And it takes the density value and the dynamic viscosity, and hence calculating the kinematic viscosity. The instrument is called SVM, and we have different models of the SVM that you can automatically calculate the viscosity index in any kind of temperature, in 40, 100, and actually I'm keeping this session to be the first session of the next version of the training. But if you have any question regarding this instrument, we can talk briefly about it now. The principle is according to ASTM 7042, and it's called Stabinger viscosity, and it's now widely used instead of the ASTM D445, which are the capillaries that Dr. Ala discussed before. These capillaries is really hard to be used, and you might purchase for many glassware to cover the wide range. However, for the SVM of Anton Paar, the Stabinger viscosity, you can use only one instrument to cover the full range of the samples, from the very low viscosity to the very high viscosity. And in any kind of temperature, we have SVM reaching from -60 until 135. The most advanced temperature control device, the Peltier device. Please let me know if you have any question, Mr. Hisham, about this instrument. I can answer you directly now.
Okay, thank you. My second question, does the device suitable for non-Newtonian and non-Newtonian system?
Yes. What kind of samples that you are talking about?
For crude oil.
Crude oil. All right. Actually, we have application for the petrochemicals, including the oil, but the crude oil, I don't have an answer. I don't know. Maybe Dr. Ala, if you have an answer for the applicability of the rotational viscometer on crude oil. Dr. Ala, do you hear us?
Hello, Muhammad. I didn't.
Hello, Dr. Ala.
I didn't hear the question.
Is the rotational viscometer applicable to the crude oil?
Yes, of course.
All right. All right. All right, Mr. Hisham, I think I wish now you get the answer.
Thank you for you and Dr. Ala.
Thank you.
Do you have any other question, Mr. Abdelati? Hello, Mr. Abdelati. How are you?
Good morning, Mr. Muhammad and Dr. Ala. How are you?
Good morning. Fine, thanks.
Fine, thank you.
My question, Mr. Muhammad, is in the transporting process for very waxy crude oil by pipeline. So you have to increase the temperature in order to make the sample flow smoothly. I have to keep it above its wax appearance. But is there a maximum temperature, for example, in a very long distance in the pipeline, the sample will lose its temperature in the way before it reach next destination. So is there a maximum to heat the sample, or heating the sample is the only way here to avoid making problem in the pipeline?
All right. Thank you for your question. Actually, in any viscometer, rotational or any kind of viscometers, if you have a highly viscous sample, you have to heat it, and there is no limit. It's a limit for the sample, the pour point of the sample. You have to heat the sample above the pour point so that it can be measured in a liquid state. And the Visco QC, if you want to measure the dynamic viscosity, the Visco QC can measure it for the highly viscous samples. It measures until the wax and asphaltene. So the highly viscous crude oil can be measured. And also you have another option for the Stamlinger viscometer that already measure the density and dynamic viscosity and also the kinematic viscosity. And this will cover any kind of viscosity range. You can put the heating attachment to your instrument to control the internal parts of the instrument heated so that the sample not being freezed while being measured. So in any case, there is no distance limit. It's according to your sample. You have to heat it above the power point, the pour point, not to be freezed during the tests.
Yes, thank you, Mr. Muhammad. But I am talking here about the transporting process. For example, I heat the sample pipeline.
Yeah, in process.
In the pipeline, you
Yes.
mean in the field, yeah.
All right.
So the minimum
Actually,
temperature, I should keep it above its pour point. But is there a maximum temperature, for example, for heating it?
all right. Actually, for the Peltier PTD control, you can use the PTD, the other type of PTD that control your temperature until 145 Celsius.
Muhammad, I think, Muhammad, please. I think he asked about some problem in the field regarding the transportation of its oil inside the pipeline. And what is the
Yes,
maximum temperature? What's the maximum temperature you need to make the petroleum or the oil transport smoothly? You mean that, yes?
yes.
The temperature it depends on your design. It doesn't I don't know what maximum temperature you may, but you may use another technique except for the temperature, like or the heating, like pour point depressant or chemicals, adding chemicals or solvents like that in the pipeline. It may be efficient more than the temperature because of the cost. I mean, yeah.
Okay, thank you, Dr. Ala.
Maybe chemical additives is cost effective than the heating.
Yes, thanks a lot, Dr. Ala and Mr. Muhammad, for your answer.
Okay.
You're welcome. You're welcome. Thank you, and thank you, Dr. Ala, for the answer.
Thank you.
Any other question, please? And you know also that Dr. Ala is with the WhatsApp group that we have. and you can ask any question anytime you want. We are happy to answer. And I think we come now to the end of the session. There are no more questions. And this is the end also of the training program Web Wednesdays, and I'm really happy that this event has succeeded, and I knew nice people like you, and we will be always friends and colleagues, and we can contact anytime in the WhatsApp group. We can share our knowledge, and we can ask any questions, and we can answer each other. We can organize other training programs later. I've asked you before to type your interests in any kind of applications, and I gathered the information, and according to that, I will organize another version of the training later, and I will invite you, and I will be happy if you all being there in the future in the next version of the training. And thank you, Dr. Ala, and I'd like to thank all the lecturers and speakers of this instrument, and thank all the attendees that added value and added knowledge and shared knowledge with each other, and all of us have got benefit from this knowledge share. And thank you very much again, and I'm reminding you to guarantee your attendance by answering the quiz of each session that you have attended. And I will prepare the certifications and send to all successful participants that have passed, that have attended at least 3 sessions and passed the quizzes of these sessions. And there will be also an announcement of the best score in the quiz. So if you have a bad score, you can enhance your score and answer the quiz again and again until you get the full mark. And see you later. And I will keep the WhatsApp group as it is so that we can contact later anytime. Thank you very much, and assalamu alaikum wa rahmatullahi wa barakatuh.
Thank you.
Thank you.